So friends, today we are going to study about practical chemistry. We are going to heat a few salts and see the effect of heat, which is important in analytical chemistry and practical chemistry. We're going to see the effect of heat first on copper nitrate. These blue colored sparkling crystals are of copper nitrate. Let us see the effect of heat on copper nitrate. I've started heating it, children. Now, as I heat this copper nitrate, let's see what is going to happen. First thing, it's going to melt and it's going to form green color because cupric ions are also green in color. Slowly this copper carbonate will also convert into black colored copper oxide. I think I need to increase the flame a little. Yeah, I'll increase the flame a little. Yes. So slowly you can see that peacock green color. Slowly it will decompose to form black colored copper oxide, and you will also see reddish brown color fumes which are coming out from this. Now right now the fumes are not they are transparent, but slowly you will see that reddish brown color NO2 gas will start coming out. Can you see that reddish brown fumes? Yes, can you see these reddish brown fumes? Yes, reddish brown fumes, pure reddish brown fumes of NO2 are being emitted over here. Yes, so whenever you heat copper nitrate, you can see that there are reddish brown fumes and it has formed black colored copper oxide. Let us see what has exactly happened when we were heating this. We have given thermal energy. We have given thermal energy to whom? We have given thermal energy to copper nitrate. The molecules started vibrating. They started bombarding on each other. They started decomposing into black colored copper oxide and into reddish brown color NO2. Okay, reddish brown color NO2. And initially copper nitrate, how it was? It was sparkling blue in color. Okay, it was sparkling blue in color. Now let us take the next salt, which is copper carbonate. You can see this is copper carbonate, sea green or greenish in color, and this copper carbonate on heating is going to give us, yes, once again it's going to decompose. As we heat it, it's going to decompose, and it is going to decompose to form black colored copper oxide. It is going to form black colored copper oxide, and at the same time it is going to evolve a gas. Which gas is being evolved? Carbon dioxide is going to be evolved. So carbon dioxide will be evolved and it will decompose to form black colored copper oxide. You can see that over here, black colored copper oxide and carbon dioxide, which is a colorless gas. Okay, so let's see on the board what has happened when we gave thermal energy to copper carbonate. Again, the molecule started vibrating, the thermal energy got converted into kinetic energy, the molecules vibrated, they bombarded on each other, and this got decomposed into copper oxide plus carbon dioxide, a colorless gas, acidic gas. You can check out carbon dioxide, it will turn lime water milky, or it will turn blue litmus paper, moist blue litmus paper red, and it is also decomposed to give you black colored copper oxide and carbon dioxide, which was colorless. You can check it with litmus paper or with lime water. Lime water will be turned milky with carbon dioxide, or else what you can do is you can also check it with KMnO4. KMnO4 solution will have no effect on carbon dioxide. It's the sulfur dioxide which has an effect on KMnO4. This was green colored copper carbonate. Okay, green colored copper carbonate. Let's check out the next salt now. Okay, the next salt is blue colored hydrated copper sulphate crystals. These are hydrated copper sulphate crystals, and what am I going to do is by heating, by the effect of heat, I'm going to release the water vapor crystallization. The water vapor crystallization is going to come out. All the water will be released from this, and when water is removed from this, okay, when water is removed from this, you will see that the blue colored copper sulphate crystals will convert into white colored copper sulphate, anhydrous copper sulphate. What's the meaning of anhydrous, by the way? Anhydrous means, you can see water vapors coming out. Water vapor is condensing on the walls of the upper walls of the test tube, right? So what's going to happen is this copper sulphate has converted into what? You can see over here, earlier it was white, earlier it was blue. Now it has converted into white. Why? Because anhydrous copper sulphate has been formed. Earlier it was hydrated. Hydrated meaning it was having some molecules of water in it. Inside the crystal, some water molecules were there in it. And when you heated this, it got converted into anhydrous copper sulphate. Water got evaporated and you got anhydrous. Anhydrous meaning completely without water. Don't get confused between amorphous and anhydrous. Amorphous is something which is completely in powdered form. It is not in crystalline form, it is in powdered form. So it is anhydrous copper sulfate, which was white in color over here, and earlier this was blue in color, right? So blue has turned to white. Now it's time to take the next salt. Next salt is zinc carbonate, but this zinc carbonate is actually white in color. But by the time I've got the chemical over here, and because it was in contact with some other chemicals, it is turned kind of mustard in color, but actually it is white in color. So when I heat zinc carbonate, again, when we heat zinc carbonate, we are going to get zinc oxide, which will again, zinc oxide has a typical characteristic of being yellow when hot and white when cold. Yeah, zinc oxide is yellow when hot and white when cold. Now you can see carbon dioxide being evolved over here. I've washed the test tube with litmus solution, so you can see the reddish flume coming, blue litmus turning red, and this zinc oxide is releasing zinc carbonate is releasing zinc oxide and carbon dioxide. Zinc oxide is the residue and carbon dioxide is the gas which is being released. And you will be able to see that this zinc carbonate, after heating, it is going to turn pale yellow. Zinc oxide is pale yellow when hot. It's because of the F centers. You're going to see that F centers during the solid state chapter. Because of F centers, this acquires yellow color, yellow when hot and white when it is cold, right? You can see that here there is a yellowish tinge, and if you allow it to cool, it's going to turn into complete white. Okay. Now, what have we done? We have done zinc carbonate. Zinc carbonate on heating has converted into, which was white. Initially, it is white in color. The one which we had got had some impurities. That's why it had turned yellow. But it will convert into zinc oxide, which is white when cold and yellow when hot. Why is it so? It is because of the F centers, which you are going to learn in solid state. Okay. Plus, it released carbon dioxide, which is a colorless gas. Okay, then we are having iodine crystals. Let us see what happens when iodine crystals are heated. You know, iodine crystals are sublime, and you will be able to see violetish flames over here now, violetish fumes over here. Can you see that? Yeah, please zoom in and have a look. You can see these are fumes, these are violetish fumes. Okay, because of what? Because of iodine crystals. And you can see that on top of the test tube, because it is colder, iodine crystals are depositing over there. So iodine on heating will obviously it is sublime, it is converted into vapors. Okay, violet colored vapors or violet colored fumes of iodine are seen when it is heated. Now last is ammonium dichromate. This is a salt, ammonium dichromate, and on heating ammonium dichromate, check what's happening. Yeah, ammonium dichromate is, we are giving thermal energy to ammonium dichromate. Yeah, so it is converted into, it's something just popped out. Okay, you can see what's fallen there, right? So this is green colored, you can say Cr2O3. Ammonium dichromate is converted into green colored Cr2O3. Ammonium dichromate has got reduced after heating. Okay, so you can see what is the reaction. Orange colored ammonium dichromate, NH4Cr2O7, even K2Cr2O7 will have the same color. NH4 twice Cr2O7, ammonium dichromate, orange in color. On heating, it did jump off also a little and converted into Cr2O3, which is green in color. Okay. Basically, what's happening is this +6 oxidation number of chromium has been reduced to +3. Okay, and that's the reason why obviously ammonia gas will also be evolved over here, and we'll balance the reaction later probably. So +6 to +3 is what is happening over here, and that's what, whenever chromium is +6, whenever its chromium has lost 6 electrons from its outermost shell, it's going to form orange colored crystals, and whenever chromium loses 3 electrons from the outermost shell, the oxidation number reduces. That means reduction has taken place, and when it is having +3 as the oxidation number, or you can say valency, then it is green in color. Okay.